Well, hello Internet, and welcome to my Python programming tutorial. You guys seem to like these videos in which I cover an entire language in one video, so I'm going to do it today with Python. I'm going to cover, like I said before, about 90% of the language, but that's pretty much everything you're going to need, especially if you're just starting out. And I have a lot to do, so let's get into it. Okay, so I'm going to show you how to install Python. It is so easy. On both Mac and PC, you're just going to go to python.org, downloads, and you're going to specifically go down here to Python 3.4.2 and click on that. And whenever you do, you're going to see all the different ways you can install it. I have Mac 10.7, so I'm going to click on this guy right here, and this is going to pop up. I'm going to hit continue and continue and continue. I'm going to say I agree, and then I'm going to say install, and it's going to install it for me. And then it's going to complete the installation, and I'm going to close that. And then I'm going to be able to go into my applications folder, and more specifically Python 3.4, and then I can either use idle or I can use PyCharm, which is what I'm going to use. But feel free to use whatever you want. Now we're going to get into exactly how to install for Windows, also equally easy. I'm going to come down here to where it says Windows x86 MSI installer. Click on that. Windows going to pop up. I'm going to click on Run, and it's going to install itself. It's going to say, is it okay if I open this? Say yes. Install for all users. That's what I picked. Click on Next. And then you have to define what directory you want. I just let it select the normal directory. Click Next. Don't really pay any attention to any of this stuff. Click on Next. And then it's going to say, do you want to allow this program to install? Yes. And then it is going to finish itself. Then you're going to be able to click on the little Windows icon over here, find Python, and idle if you want to use that. Like I said, I decided to use PyCharm for this. This is just the community edition of PyCharm, and you can get that if you go to jetbrains.com, PyCharm, download right there. And of course, you just click on this. You pick the operating system you're using, and then you click on this and you install it. Alright, so now we're inside of PyCharm. One thing you might want to do is come over here, click on Preferences or Open Preferences inside of Windows. And then a couple things you're going to need to do is come in and make sure that you have the right interpreter that you're going to use here. I'm going to go into Console and click on Python Console, and then make sure that you have the same version of Python that you just installed and you just select it or find it on your computer. And then you're also going to want to go to Project Interpreter and also make sure that Python 3.4 is also selected there. At least that's what I'm using. Alright, and here is PyCharm. And I am going to create a new project, and over here I'm going to name it hello-python.py. That's the extension you use for Python applications. What we're going to do first off is we're going to import what are called modules, which are just going to provide us with some specialty functions that we're going to want to use. One of them is a random number generator. Another one is the sys module. Put these on separate lines. And then finally, I'm also going to import the operating system or OS module. Now, if I was going to do a simple hello world, all I would do inside of Python is inside of quotes. You can either use single or double quotes. They're exactly the same inside of Python. And I would just run that. You can see hello world printed out right there on our screen. If I would want to use a comment, I would just use the little hash symbol like that. Or if I wanted to do a multi-line comment, I would use 3 single quotes, multi-line, da-da-da-da-da, and 3 single quotes once again. So that's how you handle comments inside of Python. A variable is just a place we're going to store values, and inside of Python you can store pretty much anything. There's a couple different data types which I'll explain, but you can see right there I just put name and equal to, and I put it a string named Derek, which is a string is just a series of letters, characters, whatever, in between single or double quotes like I said. And of course if we want to print that out, just go like this, and there you can see it printed. A variable has to start with a letter, and then it can have numbers or it can have underscores. So that's all we're going to have there for variables. And there are 5 main data types inside of Python, but like I said, we could take name like this and store a number inside of it and no problem would happen. But here we're just going to focus on numbers, strings, lists, tuples, and I'll explain what those are, and dictionaries or maps, whatever you want to call them. So those are the 5 main types inside of Python, and I'm going to go through each of them one by one. There are 7 different arithmetic operators. You have plus, you have minus, you have multiplication, you have division, you have modulus, which is going to return the remainder of a division. You're also going to be able to make exponential calculations with 2 multiplication signs, and floor division is going to perform a division and then discard the remainder altogether and rotate down. So if you have 14.5 as a value, it's going to change that to 14. And as an example of how that would work, I just went and put all these out here. I'm going to save that and run it. and you can see exactly how all of those arithmetic operators are going to work for you. Now, whenever you're performing arithmetic operations inside of Python, or pretty much any programming language, you have to understand order of operation matters. And basically what order of operation says is if you have multiplication or division, they are going to be performed before addition or subtraction. So for example, here we are adding 1 plus 2 minus 3 times 2. That is going to have completely different values than if we would go in here and put inside of braces the addition and subtraction. Remember, the multiplication is going to happen first in this situation. And of course, make sure that you put the braces in here on both sides of this. And also pay attention here. You can see here we have what is a string. It's in between quotes. And if we would want to perform some arithmetic, we would just put a comma right after that string. And we could have a never-ending litany of these different guys in order. And if we calculate this, you can see exactly what's going on. Order of operation definitely matters, and you definitely want to use braces anytime you can whenever you're working with arithmetic in pretty much any programming language. Now, like I said before, a string is just going to be a string of characters, numbers, whatever, between either single or double quotes. But you may ask yourself, what happens if you want to put a quote inside of there? So let's say that I want to put a quote. I would just put backslash and then follow that with a double quote. And I could come in here and say, always remember you are unique. Another thing to pay attention is we don't have semicolons at the end of here like most programming languages. And we could also, in kind of a similar way, use a multi-line string here. Let's call this multi-line quote. And this is the normal convention of naming variables inside of Python, is to use underscores between each of those. So if I wanted to do a multi-line string, I just use the 3 single quotes like that. I then could join these quotes. Like let's say I'd have a new string equal to, and I could have quote like this, plus multi-line quote. That's one way that I would join 2 strings together. Another thing I could do, I'm going to show you a couple different ways to format using print. But right now, let's say that I want to use 3 different types of strings. Well, it's actually just 2 different types. One of these strings I'm going to have embedded inside of here, like you're going to see here in a second, and then the other one I'm just going to take the 2 strings that we just created and put those inside of there. So inside of quotes, since we're using strings, I'm going to have a percent sign followed by S, and then another percent sign. And then in here, let's say I want to actually have a quote. So I like the quote like this, and then I could actually pull in the variables with the other string values that I want to use. Multi-line quote, I'll save, and there you can see. I like the quote. Always remember, you are unique, just like everyone else. Okay? You may be asking yourself, well, how can I print things out to the screen without having a new line show up every single time? Well, I could say something like, I don't like this, and then put a comma. End is equal to, right like this. New lines, and there you can see I got rid of the new line that print normally puts in there. And another thing we could do is if we wanted to print something multiple different times, a new line, by the way, is just \n. Let's say we wanted to print 5 new lines. Well, we could do just that. See? New lines. Alright, so that's just messing around a little bit. What I'm going to do now is I'm going to come in here and cover lists. Now, a list is going to allow you to create a list of values and then manipulate them. And each value is going to have an index, with the first one having the index of 0. And an index is just like a label, so we can find our way around. Alright, so let's say we want to create a grocery list. All you're going to do is put the square brackets inside of there. You're going to put everything you want to store inside of here. You don't need to have these all be strings. Some of them can be numbers. You can put any of those other different data types in here if you'd like. So, potatoes. Let's make sure they're all in quotes. Don't mess up like I just did. Go on to the next line if we'd like. Keep everything neat. Bananas. That's probably good enough. And if we would want to print the first item that's inside of our list, first item, put a comma inside of there, and then just go grocery underscore list and 0. Because remember, the first item is 0, not 1. And there you can see, first item is juice. And there it is, there's juice. We could then come in here and change the value for that item if we'd like. Again, 0 is going to be the index for it. And say green juice, and you can see green juice shows up there now. So that's how we would come in and change values. We could also print just a subset of a list. Grocery list. So let's say that I want to start with index 1 and print up to index 3, not include index 3. It's a little bit weird, just something you have to remember. You see, tomatoes and potatoes showed up there, and there's tomatoes and potatoes. You could also store those in a string by putting an equal sign here with a string name, a string variable on the side. And just to prove that we can put other things, including lists of lists, inside of a list. Let's say that I have other events, and I'm going to put wash car, pick up kids, cache check. That's good enough. I could then create another list and call this the to-do list equal to, and then we could just go other events and grocery list and store all those in one list. And then we could just print out that list, to-do list, and there you can see lists inside of lists. Okay? If we would want to get the second item, say, out of that list, the to-do list. Lists are basically boxes inside of boxes. So what we would want to do is if we want the second item out of the second list, well, this is going to be 0. So we're going to put 1 representing the second grouping. And then if I want tomatoes, which is the second item in the second list, I'm going to put 1 inside of there. And you can see it printed tomatoes. And if we look here, you can see tomatoes is the second item in the second list. We're also going to be able to come in here and append items. So let's say grocery list. And we just type in append, and let's just say we want onions inside of here, to-do list. And if we scroll down here, you're going to see onion shows up last, appends to this information that's already there. If we would want to insert a new item in a very specific index, we're going to say insert instead of append, and let's say that I want it in the second index, or number 1, put pickle inside of there. I could also come in and remove it, grocery list, remove, and say pickle. And I could also come in here and sort these items, grocery list, just by calling sort. Another thing we could do is reverse sort. Again, grocery list again, reverse. So pretty simple. And if I would want to come in here and delete an item, del, grocery list. And if I want to specifically get rid of whatever's in index 4, I'd do that. And we could come in here just to see the damage. You can also see that while I was making all these changes to grocery list, they were also affecting the to-do list. Changes to remove instead of from whatever that is. And there you can see all the different changes we made right there. Just like we can combine strings inside of lists, we can also combine lists together. Just go in to-do list 2 is equal to other events plus grocery list. We can come in and get the length of the list, the number of items, to-do list 2. We could get the maximum, or since we're working with mainly strings here, it's going to be whatever is highest alphabetically by just calling max. And then we could do to-do list 2, whatever. And we could also get the minimum item, or in this situation, it's going to be whatever comes first alphabetically by just typing in min. And there we go. Wash car, cache check. So that is a lot of what you're going to do with lists. So now I'm going to get into tuples, which are very similar to lists. I'm going to delete all this stuff. Mainly what is different about tuples is that unlike lists, we're not going to be able to change a tuple after it is created. So let's come in here and create a tuple, call this PyTuple. And why this is useful is sometimes you have data that you do not want easily to be changed. So that's whenever you're going to use a tuple. And really, if you need to change a tuple, you can convert it into a list and then change it there and then convert it back to a tuple, but that's not normally done. Alright, so if you want to see how that's done, we can go new tuple and convert a tuple into a list. You're going to do that just by typing list and then PyTuple. There we go. Now it's a list. And then after you make all of the changes that you want to make and you want to convert a list into a tuple, you just type in tuple and then PyTuple or whatever. Actually, it would be new tuple in this situation. And along with those two functions, you're also going to be able to get the length of the tuple by just using len and tuple, whatever your tuple is, new list in this situation or whatever. And also you're going to be able to get the minimum by also passing in a tuple into the min function, and max is going to work in exactly the same way. So there's the different functions you're going to use with tuples. Now we get into dictionaries or maps. Basically, I'm just going to refer to them as dictionaries because that's what I call them. And a dictionary is going to be made up of values with a unique key for each value that you're going to be storing. And they're very similar to lists, but you can't join dictionaries together like you can with lists with a plus sign. That's the main difference there. And basically, let's say that I want to create a dictionary of supervillains. What I'm going to do here is I'm going to use this curly brace, and then first off I'm going to type in the key followed by a colon and then whatever the value would be. So in this situation we're going to have superhero or supervillain names followed by their secret identity. And as you can see, it went in there, put all those in there. Now if I want to get the secret identity for one of my supervillains, let's say that I want to find out Captain Cold, I'm going to use the square brackets and then I'm going to type in Captain Cold, and you can see Leonard Snart pops up right there. If I wanted to delete an entry, supervillains again, I'm just going to type in whatever the key is. So let's say that Fiddler is no longer with us. That's how I would delete it. You're going to use del just like you did with lists. If I want to replace a villain, let's say that I found out that the secret identity for the Pied Piper was wrong. Just type in supervillains, and Pied Piper is equal to Hartley Rathway. We could also find the number or length for our supervillains. Number of supervillains we have stored. You can see 4 popped up on the right side of the screen. We could also come in here and get the value by passing in a key. So supervillains using get, which you're going to use get a lot for a whole bunch of different things. Pied Piper. You can see Hartley Rathway popped up. We could also come in here and get a list of our supervillain keys by just asking for keys. So if you play around with this long enough, you just start to remember these things because the names are just so logical. And that's one of the reasons why Python's a great first language. If you wanted to get a list of dictionary values, likewise, you're going to go get whatever your dictionary is and say, hey, I want the values. And there you can see everything pops up over here on our screen. So that's everything with dictionaries. Now we're going to jump in and look at conditionals. Now the statements if, else, and elif are used to perform different actions based off of different conditions. And those conditions are going to be whether 2 things are going to be equal, not equal to, greater than or equal to, less than or equal to. Let's go and take a look at a couple of these. And basically, the if statement is going to execute code if a condition is met. And as you're going to see here, white space is used to group blocks of code inside of Python in multiple different ways. So let's say that we have an age equal to 21. And if the age is greater than 16, there you're going to put a colon. And you see how the white space automatically popped in there? Just make sure that your white space is always the same. But if you're using PyCharm or some other IDE, more than likely it's going to do that for you. So let's say you are old enough to drive is the condition. So if the age value is greater than 16, then this is going to print to the screen. Else, if they are not, then we'll pop in here, you are not old enough to drive. And you can see you are old enough to drive pops up over there. Now if you want to check for multiple conditions, this is where elif pops in. So let's say we go if age is greater than or equal to 21, you could put something in here, a tractor trailer. And then we could go elif, I know it's weird, age, basically else if age is greater than or equal to 16, you are old enough to drive a car. And then finally, if we get the whole way down here, we're going to say print, you are not old enough. And as you can see here, I'm putting single quotes and double quotes in here just as an example that they don't really matter. And you can put that down there. Now another thing we could do is we can combine conditions with what are called logical operators. And logical operators are and, or not. Those are your different logical operators. So I'll see exactly how they work. Come in here, we could say something like, and I'm going to use brackets here to separate these. If the age is greater than or equal to 1 and age is less than or equal to 18, then we're going to do something. So this provides us for a way to have multiple conditions match. And the only way this is going to go through is if age is greater than or equal to 1 and age is less than or equal to 18. The only way this is going to work is the age is going to be equal to 1 or 18. And I'm just doing something kind of silly here. Let's say you get a birthday. So let's say we're going to celebrate somebody's birthday if they are between the ages of 1 and 18. If the age is equal to 21 or age is greater than or equal to 65, well, in that situation, we're going to say, again, we're going to have a birthday for the person. So if age is equal to 21 or 65, it's kind of explanatory, just the way that it works. Then we could say something like elif not, what this does is it does the absolute opposite. Age is equal to 30. What this is going to come back and say is if the age is equal to 30, if that comes back true, it's going to change it into false. So that's what not does. It does the opposite of whatever comes to the right of it. And here we could say print you don't get a, and then finally we could have else print you get a party. And then we'll put yay on here just so it shows up on the right side of the screen. And we'll also say something like 30 up here, changes to 30. And you can see you get a birthday party, yay shows up. Because it doesn't meet any of these other conditions, but you end up getting the whole way down here. And another thing that's very important to understand with if and else if and all these different things is if this condition is met, this is going to print on the screen, and then we're not going to go down to any of this other stuff. So once a condition is met, we're no longer going to check anything else. So that's important to remember. Now let's get into looping. And basically looping is just going to allow us to perform an action a set number of times. And let's say that we want to, and one way of doing that is with a for loop. There's actually a couple different ways. So let's say that I wanted to perform something 10 times. Well, I'm going to say for x in range, and then I'm going to put 0 to 10. In this situation, we're going to start at 0, and we're going to work up to, but not to 10, just like we did previously. So let's say I wanted to do something like print, and then x, put a space inside of here, and then let's say that we also don't want to have new lines. You can see right there that it printed out 0 the whole way to 9. So it doesn't go to 10, it just goes up to 9. But it ends up being 10 digits because we started at 0. If I then want to print a new line, not sure if I told you about new lines, \n, that's a new line. We could also use for loops to cycle through a list. So let's go and create our grocery list again, like that. We could then cycle through it, let's say for y in grocery list, colon inside of there, and then we could print y. There you can see it printed out, juice, tomatoes, potatoes, bananas. That's a nice way to jump through a list or cycle through a list, whatever you want to call it. And you could also define a list of numbers to cycle through. And this pretty much works just like a list would. Say 2, 4, 6, 8, 10. But you're defining it in the loop, print x. And there you can see it printed those numbers out. Another thing we can do is we can double up for loops to cycle through a list. So let's say we have a list of lists, so number list. And we want to put lists inside of lists. We have our brackets, and then we're going to have another bracket, 2 and 3. And then we're going to put another comma here. And then we could say something like 10, 20, 30. And then we could put another one. Well, if we wanted to cycle through these using a for loop, we could say for x in range. And since we're only going to have index 0, 1, and 2, we're going to put 0. And remember, it's only going to go up to 3, but it's not going to include 3. And then we could put another for loop inside of here in range. And we're going to do exactly the same thing because there's 3 numbers in each one of those. And then we could go print numList, and then in the brackets put x and then y. And there you can see it printed those out in order. Now let's take a look at another way of working with looping inside of Python, and that's with the while loop. Now while loops are basically going to be used when you have no idea ahead of time how many times you're going to need to loop. So one way to get something completely random is to generate a random number. And how you do that inside of Python is go random. Remember this guy right here, import random. And then we could do something like random range, which is a function that we're getting from that. And let's say we want to generate numbers from 0 to 99. That's how you do it. And then we'll get to the while loop part. Basically, we're going to say we want to continue to cycle through while random number is not equal to 15. Again, there's a white space, and we'll print out random number every single time. And then, of course, we're going to have random number changed each time. And to do that, we're just going to use this guy again. And there you can see it cycled through a whole bunch of numbers before it actually got to the part where it met 15, and then it jumped out of the loop. So it's going to continue doing this over and over and over again until this condition is met. And, of course, make sure you put that equal sign in there. Forgot that the first time. Another thing we can do is, let's say we want to actually use a while loop in another more traditional manner, sort of like a for loop. What we're going to need to do is create an iterator, and this value is just going to change over and over again. And we can say while I is less than or equal to 20. Make sure you don't put a space in there. And then we could put something like if statement. Let's say we wanted to print out all the even numbers. Well, one way to find an even number is to get the modulus of 2. And if that is equal to 0, when there's no remainder after division by 2, we know we have an even number. So let's print that out on our screen. And there that is. We could then go elif I is equal to 9. Let's say that we only want to print up to 9, even though this is saying 20 up here. I know it's a weird thing. It's just me trying to figure out a reason why to use all these different things. If we want to force ourselves out of a loop completely and not continue checking to see if I is less than or equal to 20, we're going to type in break, and that's going to handle that for us. Else, if we get down here, we want to then increment the value of I. So we're going to use shorthand notation. I plus is equal to 1. That is exactly the same, let's put a comment in here, as if we would type in I is equal to I plus 1. And yes, you can do the same exact thing with multiplication, division, and all those other different things. Just simply replace that, or replace the addition with multiplication, division, and whatever. And in the situation in which it is going to be an odd number, we're going to say continue. And what continue is going to do is it's going to skip the rest of the stuff that that's inside of the while loop that comes after this, and it's going to jump back up here to the while loop. That's the reason why we're going to increment I right there, and that's also the reason why we're going to increment I here, using the shorthand notation again. And there you can see, print it out, 0, 2, 4, 6, 8, it got to 9, it jumped out of the loop altogether and ignored everything else. So that is a rundown of how while loops work. Now we'll take a look at functions, which are going to allow us to both reuse and write more readable code. And how you define a function is you type in define, DEF anyway, and let's say that we want a function that's just going to add numbers. Well, after DEF, you're going to have your function name, and that's going to be followed by the parameters that it's going to receive. So let's just say first number, last number, put a colon, and then we could do sum num is equal to fnum plus last num. And then if you want to return something to the caller of this function, you just type in return and sum num in this situation. You're going to want to make sure that you define your functions before you call for them to use, or to use them anyway. And if you want to call the function, just call add number. There it is right there. And we could type in 1, 4, exactly like that. And there you can see 5 shows up on the right side of the screen. Now you could also, of course, just like always, type in string is equal to, take this out of here, and that's going to work in exactly the same way. Another thing that's important to know is even though sum num, this variable, is created inside of here, it is not available outside of the function because it doesn't exist outside. So if we type this in, you're going to get an error, say error, name error, da da da. If you want to look specifically, it's going to say sum num is not defined. In this situation, we would say that sum num, this variable right here, is out of scope. So it's very important to understand what goes on inside of these functions happens there and stays there unless it is going to be returned to us. Another thing that is very useful is to be able to get input from the user. And so let's say we go, what is your name? If we want to actually get the value that they type in, and you can see this is where sys is being used, we're going to go standard in and call readline, right like this. And then we could do something like print hello, followed by the name. Run it. What is your name? Derek. Hello, Derek. And it's just like the computer's talking to you. So let's take a little bit of a closer look at strings because we've been using them a lot. Let's define a string called long string. Let's say that I want to print out the first 4 characters. How I would do it is 0 for the 0 index, and then 4. It's not going to print out the 4th index. And you can see owl pops up. If I want to print the last 5 characters, something a little bit weird here we can do. I'm going to put -5, colon, and then nothing at the end of it. You can see floor shows up. And if I also wanted to print out everything up to the last 5 characters, I'm going to do something very similar again. Long string, except in this situation, I'm going to put a colon, no number in the front, and -5 again. And there you go. You can concatenate or join 2 strings together using a substring, long string, and we could do something like :4 plus be there. There it goes, I'll be there. And another way to handle formatting with strings using the print command is, let's say that I want to output a character. I'm going to put a % and a C is my, here I'm going to have a string show up, letter, and my number. If I wanted to put a signed integer, I'd put % and D. Number is, and here I'm going to say that I want to use a floating point number or a number with a decimal place, and I want to make sure that it has at least 5 decimal places. Put % down here at the bottom, and then we're going to put in all of our input. So let's say that I want to say that X is my favorite character, and for the string I'm going to have to put favorite inside of there, and number 1, favorite number, is going to be 0.14. Whoops, and make sure you put your brackets around this, and then the closing bracket. And you can see right there what it did is X is my favorite letter, and my number 1 number is 0.14. And you can see, because I put the 5 there, that it prints out 5 decimal places even though it didn't exist previous. Another thing we can do, get rid of this, is if we wanted to capitalize the first letter of a string, let's go long string and capitalize, and there it is. If we want to return the index value of the start of a string, we could do something like print long string find, and if the word we're looking for is floor, type that in. You can see that's the 33rd character right there. Just make sure that this is case sensitive, so this has to be exactly the same. If we want to return true if all the characters that have been entered in a string are all letters, we go long string is alpha. If we want to make sure that everything's a number, is all num. We could also come in and get the length of our string, long string, and we could come in and replace a specific word with another word, long string, replace say we want to place the word floor with the word ground. There you go. See, floor became ground. And something else that's useful is if we want to strip white space. There's no white space in this situation, but if there was, we just type in strip. And then if we wanted to split a string into a list, go long string and split. And then what we would put inside of here is how we want those words to be separated, which a space works out great there. And quote list. And there you can see it took that string and converted it into a nice list. So that's mainly what you're going to want to do with strings inside of Python. Now let's look at file IO, or input output. If you want to create as well as open a file, I'm going to call this test file. You're just going to call open, and I'm going to give it a name. I'm going to call this test.txt. And if I want to be able to write to this file, I'm going to send WB as my command. I could then output on the screen the file mode that was being used. In this situation, it's going to be WB by just going test file and mode. If I forgot it for some reason and I wanted my file's name, I could just type in name and it's going to print that. And then if I want to write text to a screen or to a file, I'm just going to go mention test file, write. And it's a little bit odd. You're going to have to type in bytes. And then you're going to type in write me to the file, put new line inside of there. And then after this, you're going to have to type in UTF-8. About the only odd thing we've seen so far with Python. And then finally, if you want to close a file, you just type in close. And there you can see WB and test text prints out on the screen. But you may be asking yourself, well, how do we read information from a file? Well, since we closed the file, we're going to reopen it. Equal to open. We have to tell it which one of those we want to open. Test text, and make sure you type open. And then we're going to tell it the mode here. Here we want to open it for reading and writing, and make sure you put this inside of quotes. And reading and writing inside of quotes is R+. We could go text in file and read that data out of there. And how we do that is test file and then call read. And then finally, if we want to print that out on our screen, text in file, write me to the file shows up over here. If we then want to delete that file, say we don't expect to use it anymore, this is where the OS module comes in. We just call remove and then tell it the name of the file we want to delete, and it'll delete it. Alright, so that's the major stuff you need to know for file I/O. Now let's take a look at objects. Now the concept of object-oriented programming allows us to model real-world things using code. So just like every real-world object has attributes like color, height, weight, and every real-world object has abilities like walk, talk, and eat, we're going to define attributes using variables inside of things called classes, and the abilities are just going to be functions. Now how you define these real-world objects is you use a class, which is a blueprint for creating animals in this situation. Now let's say we want to create our attributes, such as name, and none signifies a lack of a value. You can have it be whatever you want. You can put none inside of here, or you could have just simple quotes, whatever. I'll use either. We're then going to say that our animals are all going to have a height, weight, and then it's going to have a sound. Now, by preceding these variables with 2 underscores, what I'm saying is these are going to be private. And what that means is if we want to change the values here, we're going to need to use a function inside of the class that's going to allow us to change it. And if we want to get those values, we're also going to need to use a function inside of the class. So for example, if we want to set the name, we're going to do, just like every other function, we're going to type in def for define. And here I'm going to say set name. Self automatically pops inside of there. And what self means is it allows an object to refer to itself inside of the class. So for example, when I create this class animal, well, no animals exist out in the real world. So if I want to refer to an animal object, I need a way to do it, and self provides that way. So I'm saying I want to change the object's self. Kind of bad English, but that's what I'm going to use. So if I want to set the name, I'm just going to come in here, and a name is going to be passed inside of here. Then I'm going to say if I want to change the specific name, I'm going to type in self, 2 underscores, and name is equal to whatever the name is they passed inside of it. Likewise, if they want to get the name, they're going to have to use this function once again because the name is private because it has 2 underscores there. Get name, and then in this situation, I will just return self dot underscore name. And we're going to do that for everything, and this is called encapsulation, and it just basically allows us to say, hey, is the name they passed in here valid? And if it is, then we'll set it. I don't have any of that in here, but we could use something like, is it all characters? And if they typed in a number, we could say, nah, we don't like that. We demand that you enter all characters for the name, otherwise we're not going to set it. Okay, so that's what we're doing. We're verifying that the data is good. Another thing you have inside of classes are things called a constructor. And basically a constructor is going to be called to set up or initialize an object. So we're going to say define, and the constructor is 2 underscores, init, like that, and then 2 more underscores. Now in this situation, whenever an object is created, we're going to demand that all the values be passed in here. So we're going to say that we want the name to be passed in, the height to be passed in, the weight to be passed in, and a sound to be passed in. Then, whenever those things are passed in, we're going to say that we want them to be changed or defined. So, name, the sound that was passed in. See, I'm initializing, I'm setting up those objects. Now what I'm going to do is I'm going to create setters and getters for all of these different guys. And there you can see setters and getters for every single one of these different variables we have defined inside of here. And another thing I'm going to do here, this is going to be used so I can demonstrate polymorphism. I'm going to have get type, which is going to print out the object name, or the class name. So it's going to be animal, put it inside of quotes, of course. Another thing we can do is, let's say that I want to print out all of this information to the screen. Let's just create a toString here, self, and let's say I want to return. Another way of formatting output inside of Python is to use these curly braces like this to represent where you want information to go. So I could say blank is, that's going to be the name, and then I could have how tall the animal is and the weight of the animal, and says whatever the sound is for the animal. I could then follow this up with format, another way to work with these guys. And then if I want to refer, since I'm inside of the class, I don't need to use the setters and getters to refer to the values of these variables. So I could have self dot 2 underscores and name. And let's jump down to the next line. And I could go self dot underscore height underscore weight underscore sound. So those are all of the different functions and attributes I'm going to define inside of this class. Now let's go and take a look at exactly what this is going to look like as an object. I'm going to come down here, and the very first thing I'm going to create a object called cat, which is of type animal. And if I want to call the constructor, I'm going to pass the name Whiskers, and let's say that he is 33 centimeters tall, 10 kilograms in weight, and he likes to say meow. Well, now that object is created, and I can treat it like it is a regular old cat. I could also come in here and go print and cat and toString. Let's come back up here, figure out what I did wrong. Oh, that's what I did wrong, is equal to the sound that was passed in. No big deal, we all make errors. And now let's check it again. There we go, Whiskers 33 centimeters tall, 10 kilograms, and says meow. See? Now we're going to go over something called inheritance. And all inheritance means is whenever you inherit from another class, that you're automatically going to get all the variables and methods or functions that are created in the class you're inheriting from. So let's say I want to create a class called dog, and I want to inherit from the animal class. That's all I need to do, right, like that. And I automatically get every variable and every function that's already in the animal class. Then let's say I want to come in here and give it a name like owner. There we go. So every dog but not animal is going to have an owner. I can then overwrite the constructor for the animal class. Let's say I want to do something more specific here since it's a dog. Let's say that I'm still going to be able to, or still require them to enter a name, a height, a weight, a sound, but now I also require them to enter a owner name. Well, to set the owner, just like before, we type in self, 2 underscores, and owner, and make it equal to the owner value they passed in. So what happens if I want the name, height, and weight, and sound to be handled by the animal superclasses constructor up here? Well, pretty simple. I'm just going to type in super. It's the super class. It's the class above. I'm going to type in dog, and then I'm going to type in self. And then I'm going to follow that by 2 underscores, init, and then I'm going to pass in the name, the height, the weight, and the sound. Another thing I need to do is allow them to set the owner. So set owner, and owner is going to be passed in here, of course. And then I just go self, owner is equal to the owner value they passed in. Also want to do the same thing to get the owner. Just do return self dot owner. And then I could also come in here and define get type, like I said before. In a second you're going to see what this is for. Self, and have it just print that we are using a dog object. We can also come in here and override functions on our superclass by, let's go and say that we want to change the toString. If we just create a new function with a name that's already in the superclass, that's called overriding it. And might as well just come up here and just take this whole thing, paste that in there, and then let's just say here at the end we say something like his owner is, And then we put our brackets in there just like we did before. And then at the very end of this, self dot 2 underscores and an owner. And make sure you put that other comma in there. And while we're working at this, might as well cover method overloading. Basically what method overloading means is that you'll be able to perform different tasks based off of the attributes that are sent in. So let's say that I wanted to create a function here, multiple sounds, like this. And I want them to have the option to send in how many times we want our dog to bark, for example. So here's an attribute, but we're going to set this to the value of none. That means that it's going to be okay for them not to send in a value for how many. Then what we'll be able to do is come in here and say if how many is none, well then we'll just say print and self and get sound like that. Else, if they passed in a value, don't need that extra guy there. Else, if how many was passed in, then what we're going to be able to do is go else, print, and self again, get sound, and print it out how many times they say they wanted it printed out. So there's how many. Okay, so that's a way of getting around method overloading. This is just one way of saying that we do not require attributes to be sent into our function. Alright, so now that we did all that stuff with our dog, let's create ourselves a dog object, and let's call him Spot, and dog, and like I said, he has the name Spot, 53 centimeters tall, 27 kilograms weight. Let's say his sound is rough, and let's say that I am the owner. There we go. We could come in here and print Spot to string, and you can see over here Spot is 53 centimeters tall, 27 kilograms, says rough, and his owner is Derek. And then the final thing I'm going to talk about here is called polymorphism. Now polymorphism sounds really complicated, but it basically just allows you to refer to objects as their superclass and then automatically have the correct functions called automatically. And an example will probably explain it better than what I just said. So let's say we create a class called animal testing. And inside of it, we're going to create a function called getType, and it is going to receive animal objects. Then what it's going to do is it's going to refer to animal and getType. So getType, make sure that I put it inside of here. Yeah, there's getType. Here it returns that it's a dog object. And up here, getType returns that it's an animal object. Now we're going to create a test animals object of type animal testing. And you're going to see that if I go test animals dot get type and pass in a cat object, which is actually an animal object, and test animals dot get type and pass in a dog object, which is named Spot. And if I save this and run it, in this situation the cat is an animal object, it prints out animal, and in this situation it prints out dog. Alright, so that's just a way I pass in a cat, which is of type animal, and it automatically knows to go and call this version of getType. And in the other situation, I pass in a dog object, and it automatically knows to go and print the dog version of getType. So that's a brief explanation of polymorphism. And then the final thing, remember I said up here multiple sounds, and we don't need to necessarily pass in how many. In this situation, I'll show how that works. Multiple sounds, and I'll pass in 4 once, and then the second time I will pass in nothing. And there you can see, rough, 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 rough. Alright guys, so there's a rundown of the Python programming language, covered as much as I could. Hope you guys enjoyed this, and please leave your questions and comments below. Otherwise, till next time.